Hello there, 6th graders. Are you ready to kick this in high gear? And we're going to fly through this chapter. By the end of this week, we actually might be nearly all the way or done with this chapter. So, here we go. We are going to cover two things today and also skip section 4.1. Back in elementary school, you learned things about inequalities. Inequalities are as follows. An inequality is a mathematical sentence that compares expressions. It contains the symbols less than, greater than, less than or equal to, or greater than or equal to. Now, before we go any further, I want you to truthfully understand what an equation is. An equation is when you take an expression and you set it to another expression. So you have the left expression and the right expression with an equal sign in the middle, meaning that both of your expressions are equal. An inequality compares expressions. You can use these. You could also use not less than or equal to, not greater than. Anytime you put a line through it, it means not. You could say is not equal to. To write an inequality, look for the following phrases that determine where to place the inequality. So notice all of these say is less than, is greater than, is less than or equal to. If I just said less than, that means subtraction. More than, that means addition. Is means an inequality symbol. Now, a solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions of an inequality is something called the solution set. So for example, if I said, give me all the values that make this true, x is greater than 1. Well, what could be true? It could be 2, 3, 1.7, 4/3. Anything that you could plug in to make this true is a solution. And all of the solutions of an inequality are called the solution set. Something you will never, ever, ever hear me say is when I tell you to graph an inequality and I say the Pac-Man eats the bigger number or this is how you should do it. It does not, I will never tell you open or close circle because of a line underneath. That doesn't help you understand the concept. So, the graph of an inequality shows all of the solutions of the inequality on a number line. I'm going to stop there. If I said to graph the answer x equals 4, let's say you solved an equation and you got x equals 4. What you would do is on a number line, you would actually put a dot at 4 because that's the only solution. In an inequality, you're going to be graphing things that look like this. X is less than or equal to -3. So here, anything that's less than -3 is a solution. So if I said, for example, if I'm counting by 2s, and I said graph the solution to this inequality. Well, -3, since it says can be equal to, you would put a closed dot on -3, and anything that's x is less than that. So anything to the left, you would shade. So any solution that's shaded in blue would represent a solution. If I said to graph x is greater than 5, anything greater than 5 is a solution. Now you can't start at 6 because 6 doesn't take into account like 5.5. But you can't put a solid dot because 5 is not greater than itself. So you would put an open circle and you would shade all the solutions that are greater than 5, which would be to the right. It's important to note that an open circle is used when the number is not a solution. A closed circle is used when a number is a solution. An arrow to the left or right shows that the graph continues, the solutions continue in that direction. We're going to start with section 4.2, solving inequalities using addition and subtraction. So here's our key concept. Our key concept is this. We had the addition property of equality. We now have the addition and subtraction properties of inequalities. All it says is the same thing. You don't need to write this down. Let's just use common sense. If you add a number to both sides of an equation, that's the addition property of equality. If you add the same number to both sides of an inequality, then it's the addition property of inequality. If you subtract the same number on both sides, then it's called the subtraction property of inequality. So example number 1, I've actually written down the entire solution process for you. Here it is. Solve x minus 5 is less than 3. Before we go on, I have a huge hint. To solve an inequality, here's your study tip. You're going to actually use the same operations you use when you solve an equation. The exact same thing. So here's my inequality. X minus 5 is less than negative 3. You then, to undo the minus 5, would add 5 on both sides by something called the addition property of inequality. You then simplify, you get x is less than 2. Now to graph this, you would put an open circle on 2 because 2 is not a solution. 2 is not a solution. So you're going to represent it by an open circle. Everything less than 2 is a solution, so you shade everything that's less than 2. So, for example, 0 is less than 2, you would shade that direction. 5 is not less than 2, so you do not shade to the right. You would shade to the left. So example number 2, let's solve this inequality. 13 is less than or equal to x plus 14. We're going to follow the same rules, and I know you know what to do here. You subtract 14 on both sides by using the subtraction property of inequality. That gives you negative 1 is less than or equal to x. Here is the common mistake I see. Do not ever do this. No, bad. We graph this. Okay, so it says negative 1 is less than or equal to x. Well, since negative 1 can be equal to itself, I'm going to put a closed circle. Negative 1 is less than x, so negative 1 is less than x, so I shade to the left. Why is that wrong? It says less than. Why don't I shade to the left? Because the sign is not actually less than. Yes, it says less than, but you have to look at the relationship to the value of the variable. So, here is your hint. The inequality negative 1 is less than x is the same as x is greater than or equal to negative 1. If negative 1 is less than or equal to x, that means x is greater than or equal to negative 1. I didn't flip anything. People think, oh, you're flipping the inequality. No, I'm not. I'm just rewriting the problem. It's the same thing as saying x is equal to 1. 1 is equal to x. It's the exact same thing. So this, no, not right. No, not correct. If we graph this, it says x, which is our solution, is greater than or equal to negative 1. That means I would have a closed circle on negative 1 because it is a solution, and everything that's greater than negative 1 is a solution. So I would shade to the right. Our last example in this section is example 3. A person can be no taller than 6 1/4 feet to become an astronaut pilot for NASA. Your friend is 5 feet 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. So step 1, I'm going to let x equal the possible amounts your friend can grow. So x is the possible amounts your friend can grow. So how tall is your friend right now? Okay, well, it's 5 feet 9 inches. So we know your friend can grow X amount from 5 feet 9 inches. But because this problem is in feet, we have to convert 5 feet 9 inches. 5 feet, 9 inches means that we have 9/12 of a foot, which means we have 5 3/4 feet. As a decimal, that would be 5.75. So 5 3/4 feet plus X number of feet, but it says your person can be no taller. That means your friend could be 6.25 feet, but can't go over it. So the inequality that you would write would be that your height, your friend's height, has to be less than or equal to 6.25 feet. So we solve this by subtracting 5 3/4 feet on both sides. And that gives us X is less than or equal to 0.5. I'm going to tell you right now, you circle that as your answer, I guarantee you it'll be wrong. Absolutely 100% wrong. This makes no sense to me. I want you to write it in words. You must write it in words. So how much can your friend grow? Your friend, let's see if I can actually spell friend right. Your friend can grow. You cannot say half a foot. Your friend can grow no more than half a foot, or you could say 6 inches, because your friend could grow 2 inches, 1 inch. Your friend may not grow at all. That's all okay. But your friend cannot grow any more than half a foot. And bam, we're already to section 4.3. Wow, we're flying through this. We're now going to use multiplication and division, which is basically the same thing as when you solved equations. All right, now this is going to be a little different. Case 1. You don't need to write this down, but multiplication and division properties of inequalities. This only works with positive numbers. Positive numbers. If you multiply both sides by a positive number of an inequality, you're using the multiplication property of inequalities. Same thing is true with division. If you divide both sides by the same positive number, you're using the division property of inequality. So here's our example 1. Solving an inequality using multiplication. I am going to multiply by the reciprocal. The opposite of multiplying by 1/5 is timesing by 5. And it's the same thing as looking at this and going, well, what's the opposite of divide by 5? It's multiplying by 5. So the 5's cancel. You're left with X is less than or equal to negative 15. But now we graph this. So negative 15, negative 14, negative 16. We would have a closed circle since our solution could be negative 15. And anything less than negative 15, so we shade to the left. And yes, negative 16 is less than negative 15. And that would be my answer. Example number 2. Solve the equation 6x is greater than negative 18. What do we do to both sides? We divide by 6. So x is greater than negative 3. If you graph this, what kind of circle would I have on x is greater than negative 3? Open. Why? Because it's not a solution. Which way would I shade? My solutions are greater than negative 3. If you don't know, look at your negative 4 and plug it in. Is negative 4 greater than itself? Nope. So you would not shade to the left. You would shade all numbers to the right. So the next key idea is the second case. When you multiply or divide each side of an inequality by a same negative number, the direction of the inequality symbol must be reversed in order for the inequality to remain true. So look at what happens here. If I multiply an inequality by negative 2, your inequality must be reversed. If I divide both sides by a negative, my inequality must be reversed. Now this is also called the multiplication and division property of inequality. Example number 3. Negative 3/2 n is less than or equal to 6. I have to get rid of a multiplication of negative 3/2. Just like what we did before, we can divide by negative 3/2, which means you are multiplying by the reciprocal. So I am multiplying by negative 2/3. This cancels. You're left with n is less than or equal to, wait a minute, let's erase that. 6 times negative 2/3 is negative 4. Because this number is negative, the number that you multiply both sides by, your symbol, your inequality symbol must be reversed. So the less than or equal to becomes greater than or equal to. And if you graph it, it would be a closed circle on negative 4 because it is a solution, and anything to the left of negative 4, to the right of negative 4, since it's greater than, would be graphed. Example number 4. Negative 3z is greater than negative 4.5. I would divide both sides by negative 3. That would give me z and positive 1.5. But because I use the division property of inequality, I have to reverse with a negative number. I must reverse the inequality symbol. So it's going to become less than. This negative here does not matter. It's only when you divide or multiply by a negative number. The top number does not matter. It could be negative or positive. It's this number right here. If you divide by a negative, it's going to reverse. If you graph this, you are not on a number line going to put 1.5. You are going to put a dot between 1 and 2. It's open circle since it cannot be a solution, and you would shade everything to the left.